still game 6. Let's try to understand it first. So we are playing this game. It's gonna be the still game. So there are n stills in a pile. Each player's turn, they can remove a still from the pile and receive points based on the still's value. Alice and Bob may value the stills differently. So this is gonna be the differently. So for Alice at index 0, it's gonna value. Let me just clear it first. Yeah. So at index 0, so for Alice will get a score of 1. But at index 0, Bob gonna get a score of 2. At index 1, Alice gonna get a score of 3, and Bob will get a score of 1. Yeah, so this means if Alice chooses the index 0, Alice gonna collect a score of 1. But what about Bob? Bob cannot collect 0 because it has already taken. Bob can only take a value of 1. Yeah, so what about Alice take index 1? So Alice gonna get a score of 3. And what about Bob? Bob can only get a score of 2. So what is the optimal way? So it's going to be 3 minus 2 because this is bigger. 1 minus 1, it is 0, and 3 minus 2, it is 1. So definitely Alice will play optimally and get a result of 1. Yeah. So now, how should we solve this problem? Let's check the value of n. It is 10 to the power of 5. It means normally by n squared we cannot solve it. We have to use some clever way to solve it. Let's just check the final return. So the winner is the person with the most points after all the stills are chosen. If both players have the same amount of points, the game results in a draw. Both players will play optimally. Both players know the other's scores. So this means if Alice wins, we're gonna return 1. Otherwise, Bob wins minus 1. And if they have a draw, we're gonna return 0. Yeah. So if Alice collects a score, Alice definitely will get the value of this one. And Alice can choose it from anyone. It not means from left or right side. It means any value if it is okay. So definitely Alice will choose it. And then Bob will choose the still just after Alice removes that one. And then Bob will choose maybe the maximum. So according to this way, maybe this gonna be solved by some greedy ideas maybe inside, because definitely n is 10 to the power of 5. Yeah, but if it is a greedy problem, we definitely need to get some mathematical formula to get the result. Yeah. So let's just start to analyze the problem like this. So we are going to play it. But at some point, at some time t, at this time, definitely Alice will collect some scores. It's gonna be, let's say, it's gonna be x. And for Bob, definitely will also collect some scores. And the score is y. Yeah. And we want to calculate the maximum of x minus y. Yeah. But how can we calculate it? So imagine there is only 2 stills left behind. We finished all the calculations, all the previous calculations at time t. It means if the array is very long at these areas for Alice and at these areas for Bob has already finished the calculation. And what we left behind is only this value 1, 3, and for Bob 2, 1. Now our problem might become easier to analyze. So for Alice, it has only 1, 3, and for Bob, for the score, it has only 2, 1. It means we have only 2 stills left behind. We finished all previous calculations, and the sum of Alice is x, and the sum of Bob is y. Now we have only 2 stills. What are we gonna decide? So maybe Alice will get a still of maybe A. Let's just say this A. And Bob will get a still at place B. Definitely it's gonna be the different places. Maybe this is the index 0, this is the index 1, and the final result gonna be x plus A minus y plus B. So this is gonna be difficult to calculate because this xy is fixed, it is okay, but for this A and B, it is in the different index. So for example, this may be the index 0 and another one may be index 1. Definitely we cannot calculate it so easily because they are at the different index. If we use brute force, definitely it will not work. Yeah. Now we're gonna turn this problem into some easier part. So what about we just put the two values to Bob first, and then Bob will give one value to Alice, because it's the same idea, but the formula gonna be different. If we get an easier formula, we might solve the problem. Yeah. So now, similarly for the problem, what about we put all the values to Bob first? Yeah. Now, for this y is for Bob, and we put all the values for Bob. So this 2 and 1, the value, the 2 plus 1, this is 3, we're gonna give it to Bob. So Bob definitely will get a value. Yeah. So for Bob will get a value, and this value gonna be, let's say, Bob will get a value. Let's say this value gonna be inside this y. Yeah, maybe Bob will get some value of b. 2 plus 1 it is 3, and we're gonna plus this y. Yeah, so we're gonna put this value just inside this y. This means so for x, it is some value. What's left behind is only this 1 and 3, but definitely this x can still choose 1. And for this Bob, it will include this 2 and 1. It will put all the values to this y. Yeah. So in this way, this means y must minus some value, and then it should be the real value for the Bob. And for this Alice, must plus some value, and then this value should be for Alice. And now we're gonna decide which value we're gonna plus and which value we're gonna minus. Let's try to enumerate the problem. So if we choose a value of 1, so x will plus a 1. So for this y, definitely it's gonna minus a 2, because this one has already taken. Before that, Bob has already taken both of them. Now Bob has to minus 1, because this is taken, this must be removed. So it's gonna be y minus 2. And what is the final result? Yeah, so the final result is gonna be x. Yeah, so the final result is gonna be x minus y plus 1 minus 2. 1 minus 2, it's gonna be plus 3. Yeah. So this is one way. What about another way? If x plus a 3, so definitely this Bob y gonna minus a value of 1, because it must be at the same position. If it is at the same index, it is at index 1. So this y gonna minus 1. So 3 minus 1 is gonna be 4. Definitely we're gonna choose this value, x minus y plus 4, because 4 is bigger. Now it seems the problem is clear. Because x minus y is fixed, because we define the problem to be fixed, and then we just need to plus a value, and we're gonna plus the maximum value. If this value is maximum, definitely we're gonna choose the maximum value first. And why we are choosing this maximum value, it is at the same index. If it is at the same index, normally we can solve it easily by sorting. Yeah, so this is a great idea. Now we're gonna turn this problem into a formula. Yeah, so now what about only 2 still left behind? So for this x, it's gonna minus plus a value. So x gonna plus a value maybe a, and Bob gonna be minus a value, and what's left behind maybe b. So the formula gonna become x plus a minus y minus b, and the final result gonna be x minus y plus a plus b. And for x minus y, it is fixed. And for this a plus b, it's gonna be a numerator of all the values from index 0 to n minus 1. It means this is sum of all the values. So 1 plus 3 is 4, 2 plus 1 it is 3, and we're gonna choose the maximum value first, and then we're gonna choose the smallest value. It means this value is gonna be for Alice, and another one for this 3 it is for Bob. But while choosing the values for this 4, but while choosing these values for this 4 is plus of them. Definitely, it means Alice will choose a score of 1, and Bob will choose. Let me check. Yeah, so it means Alice gonna choose this for just means at this index 1, Alice will choose a score of 2. Alice will choose a score of 2. Yeah, so this means Alice gonna choose a score. If Alice choose a score of 1, so Bob gonna choose a score of 1. If Alice choose a score of 2, Bob gonna choose a score of 3. Yeah, so definitely the final result gonna be this one. Alice choose a score of 1, and Bob choose a score of 1 because it is 0. Otherwise, if Alice choose a score of 2, Bob gonna choose a score of 3, it's gonna be become smaller. Yeah, definitely this is gonna be the optimal solution. So 1 plus 3 is bigger than 2 plus 1. Yeah. Now let's get to the code to finish the problem. Yeah. So according to this idea, definitely we're gonna put the Alice value and Bob's value together. So we're gonna zip it inside. So for I'm gonna prepare a pairs. So the pair is gonna be a zip. Yeah. So it's gonna be let me put Alice and Bob. So for AB, we're gonna put it a zip. Yeah, let's just use sorted list because we're gonna sort it together. So we're gonna sort the list, and it's gonna be a zip, and it's gonna be Alice values and Bob values. And then we're gonna use a lambda function. So in this lambda function, it's gonna be the sum of them. So we're gonna have a value of x and sum of x. As we're going to choose the maximum value first. So for example, it is this is 3 plus 1 first. So this means the sum of them, we're going to choose minus the sum of them. Yeah. Now let's just check what is inside this pairs to check if it is as we expected. Yeah, let's just check these pairs if it has been sorted according to the design. Yeah, the sorted expected 1 argument got 2 argument. Yeah, let me just use a list maybe. Yeah, let me just use an array. We cannot do it like that. I have to enumerate for an array first for this zip. Yeah, so we're gonna prepare an array inside the zip. Yeah, so we're gonna prepare a tuple of AB. So for AB in zip, and then we're gonna sort this array. Let me try to run it. Oh. Yeah, let me prepare an empty array first. I don't know what is wrong. I'm gonna sort the array. So inside it's gonna be tuple. So AB for AB in zip of Alice value and Bob's value. I don't know what is wrong. Yeah, let me just just prepare an empty pairs first. So for AB in zip, Alice values and Bob values. So I'm gonna put the pairs inside. Yeah. So pairs append with the tuple of A and B. Yeah. Now I'm gonna sort it. So I'm gonna use it this way. So pairs dot sort, and I'm gonna have the value of the pairs, and I'm gonna define a lambda function. It's gonna be x and minus the sum of x. Yeah. Now let's check what is inside of the pairs. Yeah. Now it seems that at least this pairs is okay. As you can see, 3 and 1 first. Yeah, because we zip 3 and 1 together, and the sum of them gonna be 4, so it's gonna be first here. But normally this can be one line. I don't know what maybe I did something wrong with it. Yeah, let me try to use a sorted. It's gonna be sorted. A tuple AB. So for AB in zip of the values of the 2. Yeah, maybe I forget to write the k for this lambda function. I don't know. Let's just have a try. So we're gonna sort it array, and we have a lambda function here, and definitely we're gonna get this kind of pairs. Yeah. Now as you can see, it works, but it is just one line. It is the same idea. Yeah. Let me just go back to check what I did wrong for this zip. I forgot about it. Yeah, I forgot to put the k equal to lambda. We must to use k equal to lambda. We cannot use lambda directly for the sorting in Python. Yeah. Now let me just run it. So now we're gonna turn this problem into one line, and after we have the pairs, basically we can use these pairs to calculate. Because if we get this kind of 3, 1, 1, 2, and for the first term it's going to be Alice. Alice will definitely choose this kind of value. This is score 3. Yeah. Now let's just take the values for Alice first. So Alice is going to be an array, and inside it's going to be take the even index. And for Bob, it's going to be an array, and Bob will take the odd index. So it's going to be here going to be 2, and the first place is going to be 1. So this is a Python. We're going to use Python to write it like this. So this means for this array, Alice will always take the even values, and Bob will take the odd values, because this way will be the optimum solution. And finally, we just need to return if Alice equal to Bob, and we're gonna return 0 because it is a drawn. Otherwise, we're gonna return 1. So if Alice is more than Bob, otherwise we're gonna return -1. Now we just need to put it inside, and this is easy. So this is A. So for AB, inside the pairs, and another one we just need to copy it, and it's gonna be B, the next value, the index 1. Yeah, because this value, this score is just for Bob. Yeah, now let me just run it to check if it works. Bob is not defined. I need to put a Bob here. So this is gonna be the Bob. Yeah, now as you can see, it works. Now let me just submit it to check if it can pass. I need to Alice more than Bob. Yeah, I expected it to be -1, but I gave but my output is 1. Yeah, because of this is gonna be 2. Yeah, let me just print it out to tag the Alice and Bob. Yeah, I think I needed to sum up all the values. I forgot to sum up all the values. So here it's gonna sum up all the values. Otherwise, I cannot compare. You know, I needed to sum up with all those values, and then I can compare with them because I forgot to put the sum. Now let me just run it and put it inside the example to have a tag. Yeah, let's try to delete this one, and so this is for Alice. It is gonna be the sum of all the values, and this is gonna be the Bob. It is the even values, and this is the odd values, and the time complexity is n log n. Yeah, now let me just run it. As you can see, it works. Now let me submit it to tag. Yeah, as you can see, it works and it's pretty fast. I think the difficult part is how to analyze this kind of sorting. If we basically solved this kind of sorting, basically we can solve the problem easily. Thank you for watching. See you next time.